In this video, let's take a look at margin of error. Our formula to calculate the basic margin of error is approximately 2 times the standard deviation divided by the square root of the sample size that we call n. The number 2 is used because the value we use for a standard 95% confidence level has a z-star value of 1.96, which rounds up to 2. Now, we don't have to worry too much about z-star values in Math 3, but in a later statistics course, you would learn more about those. But let's just look at a couple of examples that involve a basic margin of error. According to a study in 2014 by the RAND Corporation, in the U.S., 9.3 million more people have gained health coverage over the previous year with a margin of error of 3.5 million people. And it asked in Part A, what is the least number of people that have gained coverage based on this study? So the least number of people would be to take the number they found, so 9.3 million, and you want to subtract the margin of error of 3.5. So I would just take 9.3 minus 3.5. So I'm going to type that in. 9.3 minus 3.5, and I get 5.8 million people. So don't forget that we're talking about millions of people. And in Part B, it says, what is the most number of people that have gained coverage based on this study? So you take the 9.3 million that they found and you add the margin of error of 3.5. So I'm just going to type that in. 9.3 plus 3.5 gives me 12.8 million people. And that would be all I would need to do to answer that question. Number 2 says a company recorded the number of employee absences each week over a period of 12 weeks. The company has 75 employees and found an average of 4 absences per day with a standard deviation of 2.64 days. Calculate the margin of error for the company's observational study. So if they have 75 employees, that is the sample size in this case. So we're going to say n equals 75. They found an average of 4 absences per day with a standard deviation of 2.64. So we would say, based on our formula, that approximately 2 times our standard deviation, which is 2.64, divided by the square root of our sample size will give us our margin of error. I'm going to abbreviate that with MOE. So I just need to type in 2 times 2.64 divided by the square root of 75, and I get a margin of error of approximately 0.609, or we could say approximately 61 if we needed to round it further. But that would be all we need to do if all we need to do is calculate the margin of error. Number 3 says there are 1,000 light bulbs in a school. Over the school year, the custodian recorded the number of bulbs that burnt out and needed to be replaced each month. The custodian found that an average of 30 light bulbs needed to be replaced each month with a standard deviation of 12.78. So calculate the margin of error for the number of light bulbs that needed to be replaced each month. So we have 1,000 light bulbs. So that's our sample size. Our standard deviation, which is our S in our formula, is 17.28. And so our margin of error is approximately 2 times 17.28 divided by the square root of 1,000. So you're multiplying the 2 by all of that. If you want to, you can put it all in parentheses like I did in my calculator. So 2 times 17.28 divided by the square root of 1,000. And we get that the margin of error is approximately 1.092, or approximately 1.1 if we need to round that far. For number 4, it says a statistics student did a survey for a class project. The student asked 25 male students and found that their average height was 68.1 inches. However, the student found that his margin of error was larger than he wanted it to be. How can the student lower the margin of error for his study, for his survey results? So in order to lower the margin of error, you always need to increase the sample size. Increasing the sample size will make it closer to the actual population, and that will always decrease your margin of error because your data is more accurate when your sample is larger, because like I say, then it's closer to the population which we're always trying to find something about. So that is, I think, all we need for these examples.